Well, good morning. Thank you for the introduction, and thanks to the Consumer Electronics Society, the leadership and the organizing committee for inviting me here. I'm thrilled to be at the Consumer Electronics Show here in 2015 and ICCE. I was here last year as well, and try to stay awake if the lights are out. It's been interesting to see the developments since the last time I was here. And the subject I'm going to talk about is related to consumer electronics. It's related to cloud computing, and in particular, what we can do as participants in this ecosystem to advance the technology for the benefit of humanity, which is the IEEE's mission. In addition to my IEEE roles, in my day job I work for EMC Corporation, and although I'm not speaking for EMC today, I am going to talk with you about how IEEE is participating in all of these elements and how you can make a difference going forward in what I call the next computing platform. A week or two ago, I was in Singapore speaking at the IEEE CloudCom conference, and a friend of mine there asked me what had changed since my last trip to Singapore. Well, it turns out, although I've traveled quite a bit around the world in the last 30 years, I hadn't been to Singapore for 35 years. Back in the mid-70s was my last trip to Singapore. And so I started thinking about what had changed since my last trip there. And I'm an old semiconductor guy. I'm an old guy and I'm a semiconductor guy, and it's kind of where my heart is, although I haven't been in the semiconductor business for quite some time. But that was the yardstick I started thinking about, and I started thinking about how that would inform what I'm calling the next computing platform and what that would mean to people. So I made a slide for that event, and I'm going to talk about it briefly in terms of a preamble to going forward. For those of you who don't know, Yogi Berra was a famous baseball player and coach, and has a tendency to make seemingly philosophical statements that are often humorous. But there is a kernel of wisdom here in this, and it's especially apt for people who are old enough to remember things that happened a long time ago. Because what happened in the past is sometimes useful in understanding what could happen in the future and what we might do to make it happen. And that's what I'm going to talk about today. Back in the 1970s, I was running the microprocessor group at a company called Synertech, which was owned by Honeywell, and we made the 6502 microprocessor. For those of you who are old enough or are historians, that was the microprocessor that made the Apple II work. Also the Atari VCS games, and good. So there's two of us. Three, all right. Four. Oh, that's really worrisome. Used to be more. Oh, there's five. Okay. Anyway, I thought I would look at the current hot announced Intel processor just to see what had changed in the intervening years that I hadn't been in Singapore. In fact, I had gone to Singapore working for Synertech because that's where we were assembling our microprocessors. We made the die in Santa Clara on Stender Way in the middle of Silicon Valley. We shipped the die to Singapore, and our factory in Singapore put them in a 40-pin plastic dip package, shipped them across the street to Apple's Singapore facility where they made Apple IIs out of our chips and a few other things. But what was interesting in putting these things together, I hadn't really appreciated the incredible change that had happened. The transistor count, for example, we had 3,500 transistors in the 6502. That was a lot of transistors, actually, in those days. but it actually was also all you needed to make a microprocessor. The Intel 15-core Xeon Ivy Bridge EXV2 has 4.3 billion transistors. Now, a lot of that is memory, but we didn't have any real memory other than registers on the 6502. In the Intel chip, there's a 37.5 megabyte L3 cache. We didn't have an L3 cache or an L2 cache or any cache, just registers. The other thing that was interesting is the number of pins. We only needed 40 pins, and Intel needs thousands of pins for this to work. Power dissipation, quite a huge increase. Well, that's not surprising given the frequency going from 1 megahertz to 2.8 gigahertz and the number of transistors. The price is also interesting. There's a couple of order of magnitude increase in the price from what we charged for the 6502. In fact, that's one of the real reasons that the 6502 was chosen by Apple, was that it was only $25 when it was announced in single unit quantity, and that enabled a couple of guys in a garage to afford it. Plus, we gave them a line of credit. But this incredible technological change, I think, is nothing compared with what we're going to see in the future. And that technological change is all around consumer electronics and how consumer electronics relates to humanity. I've been talking for a number of years about the cloud computing wave, but I really think that's just the beginning of what we're going to see. And it's people in the consumer electronics industry that are going to have the largest impact on what happens to the quality of life going forward. This isn't just about making better computers. I think microprocessors and similar technology improvements have made computing much more affordable and ubiquitous. Cloud computing has disrupted IT around the world. It's made it possible to build company IT infrastructures with no capital equipment. But when you add the next few elements to this, it creates a life-changing opportunity, and I think that's something that we all should be thinking about and we all should be involved with. In particular, the IEEE is a unique place for addressing this. We have both the technological expertise, the standards expertise, and groups such as the Society for Social Implications of Technology, which are focusing on how this technology affects humanity. And I think we have to be careful about how that works. In particular, as I've been calling the cloud wave, the fourth wave of computing, what's happened since then, I think, is even more interesting, which is the mobile, social, big data, and Internet of Things. These things have transformed what computing means to people. The next leaf on the next onion skin that's happening is cyber-physical systems. This is where the world of the cloud computer, the mobile, social, IoT world, actually interacts with the physical world. Cyber-physical systems are actuators where these computer resources reach out and touch you and adjust things, and sensors to find out where you are, what you're doing, how you're feeling, what you're thinking, and so forth. And then the computer system that's being developed in front of us from a bottoms-up standpoint, not a top-down standpoint, will change the world. So we're going to be creating this feedback loop where sensors create data which is analyzed by the cloud system and actuates the world. We'll be creating a feedback loop that hasn't been designed. We're going to grow that from scratch. Now, those of you here who have been around long enough in the computer world probably remember typing on terminals. If something went wrong with a terminal, you unplugged it. Somebody came, brought another terminal, nothing bad happened. The next platform was the PC, LAN, client server, workstations, Sun Microsystems, etc. They were really more powerful computers, but they were interconnected. But the interconnection was really in the computer domain. If something went wrong, your program crashed, the data was wrong, okay, we'll have to get the data fixed, we'll have to have somebody come in and change the networking parameters. But the impact of that was in the world of cyberspace. This third platform, where we'll have billions of users, hundreds of billions, or maybe a trillion things, this cyberspace is going to connect with the real world. It's going to interact with the real world. You won't be able to call somebody and unplug it and change it if something's going wrong. That interaction will just continue. So how do we build a computing platform, a new platform of computing that lives in this kind of world where all the pieces are connected in real time, 24/7, and we're actors and we're acted upon. And most of those things that are going to act upon us and that we're going to act on are consumer electronics devices, and that's why we're here. So one of the things we're learning is that in many of these services that we're accessing over the intercloud today, we're the supplier, we're not the customer. So we're generating on an average of about a half to a gigabyte of information per human per day, and that is being processed, crunched, packaged, and sent to people who use it to create products and services that they sell to us. So we're both the supplier and the consumer in this space, but of course we're not necessarily aware of what's going on. The second thing that's happening with these numbers of things, and there's lots of different forecasts about how many things we'll have, whether there'll be hundreds of billions of things or tens of billions of things. Anyway, it's a lot of things. And you can see if you go to a meeting, I speak at a large number of standards meetings. If we have 100 people in the room, we're definitely out of IP addresses, halfway for the room filling, because people have 3 or 4 or 5 devices looking for an IP address at the same time. I'm sure some of you are that way. I see Stuart. I know he has a Dick Tracy watch on as well, which I have to get now. It's too bad the show's over, but I need one of those. But with a laptop and a tablet and a smartphone and a computer, and maybe you have 2 different types of tablets, all these IP addresses are being sucked up. But what's more interesting is all of those accesses that you're going to the internet are being logged, monetized, converted into data, and then somebody is running big data analytics on that information and turning that into revenue, or trying to turn that into revenue. Later, that analytics will be turned into action. Things will happen in the world physically because of that. That's what's different with cyber-physical systems. Okay, so what does this future platform look like? Well, I think it looks like clouds aggregating themselves into clouds of clouds together with things. So I think from a high-level standpoint, we today, of course, have people building clouds, but they're not federated, and I'm going to talk about that in just a minute. But those clouds, if they were federated, could self-organize, self-optimize, and considering the things that are in the right vicinity, create a platform that includes both things, clouds and clouds of clouds. Now, notice nobody has planned this out. We haven't thought this through. This is in a way just like what happened in the generation of the internet, where we started deploying resources and people started asking questions. Well, how do we do this? And then we figured out how to do it. The difference here in this space is that these actuators are going to be actuating things in the real world before we've really figured out how to make this work from a top-down standpoint. So it's an interesting challenge. I want to talk about federation because I think it's the key missing link to go from where we are today in the cloud space to where we need to go. And what I mean by federation is multiple distributed systems that can talk to one another interact with one another, affect one another without any interaction of human beings. I think that's the essential difference. I don't know how many people here still make telephone calls. It's a lot fewer than they used to be. But in the olden days, if you wanted to call from San Francisco to New York, you had to talk with somebody called an operator. Has anybody here made a phone call that had to go through an operator? Right. Okay, well, so that operator actually got a call from you and had to patch through and make some key presses to send your call on forward in order to complete that call. That's obviously not a very scalable or cost-effective way of doing things, and it took 83 years from the time the first commercial telephone exchange was built in 1878 until international direct distance dialing was rolled out worldwide, where you could actually dial, and it was a dial in those days like I have on the picture. There was a wheel with holes in it that you put your finger through and you had to spin it around. It took 83 years until that happened. Without that federation, the telephone system would have been forever limited. The next generation of federation that you may remember is email. How many of you remember when you couldn't send an email to someone without knowing who their service provider was? Okay, a few more people. So if somebody was on Prodigy and you were on CompuServe, sorry, you couldn't email them. You could try and talk them into moving to CompuServe, or you'd move to Prodigy, or most likely you'd pick up the phone and talk to them because that was easier. Clearly that wasn't a scalable system either. Again, that's an example of lack of federation. What was the solution to that? Well, a bunch of standards, some of which were IEEE standards, many were IETF standards that were developed to connect everything together and allow mail servers to talk to one another without humans in the middle. It's the human problem. Getting humans out, letting the computers talk to one another is how to do the federation. And that's what happened and created what we see today as the internet, that explosion of value of commercial assets and benefit for humanity came about because of federation, and that federation was enabled by standards. Those same ideas apply here in the cloud space, and they're also dramatically relevant to what IEEE can do. So we're in the same boat today as we were back in the email world, where multiple cloud providers with multiple different cloud services don't have federated services. That is, you can't write an application that runs across all the clouds in the world. Suppose you needed all the cloud resource in the world. You couldn't do it unless you staple together multiple clouds with your own work. And it's a very difficult task. I remember many years ago when I worked at National Semiconductor, we were trying to build a 32-bit processor in the days when that was very, very hard. One of the design groups that was working on the processor was in Israel, and they were using 25% of the computing power of the country to do the simulation for the chip. There wasn't enough computing power to simulate the whole chipset, so we could only simulate the CPU. We couldn't run a simulation with the CPU, the MMU, the FPU, and so forth. And the way the engineers handled the inter-chip testing is they would talk to one another over the partitions, and they'd say, well, okay, now if this signal goes up, what happens over there? Okay, that goes down, and then the FPU guy would be over there, and they'd discuss this over the partitions because we couldn't simulate the whole chipset. Well, actually, we could never get the whole chipset to work because we couldn't do that. If we'd been able to write an application that used all of the computing power in the country, then we would have been able to simulate the chipset. There may not be an application in your corner of the world that needs that much computing power, but there are applications that need tremendous computing power, at least for a short period of time. And today you can't do that. So the answer is federation, and it's a particular kind of federation. I want to talk about two ways of doing federation: the multi-cloud approach and the intercloud approach. Multi-cloud is what we have today. That is, there are multiple cloud providers. They have APIs. You can write to the APIs. You can write to multiple cloud provider APIs. So if you want to compose an application that runs across several cloud providers, you can do that. But the onus is on you to write the application running across multiple APIs. There are cloud mediators who will provide a service to abstract a different API and then interface with multiple cloud providers. Our own Raj Kumar Bhuya, who many of you know, is a principal in a startup that does this called Monrosoft. He tells me it's extremely difficult to keep up with the API changes that are going on at multiple cloud providers in real time. A very painful process. You can do that, but that's not really the answer to this problem. The answer is what we call intercloud. Cloud providers exposing a common intercloud API along with their own provider APIs allow you to write an application that runs across many clouds. Now, there are some assets that are needed to make this work, just as we had in the world of the internet. Think DNS, for example. You need a route to find things. You need a way to mediate control. We call that an intercloud exchange. And you need a way to mediate data and interchange. With this model, you can write applications that play across the entire universe of clouds. That's what we call the intercloud approach. And I'll talk about what IEEE is doing in this space. Now, I mentioned earlier that standards were a key part of the creation of the internet. Without TCP/IP, without DNS, without those standards and many others, DHCP, SMTP, etc., we wouldn't be here today playing games and reading your email. You'd have to listen to me. But those things have made the internet happen, just as I think a critical set of standards are needed to make the intercloud happen. And they don't all have to be done at the same time. The standards I mentioned were not all done at once. They don't all have to be done by the same organization, and the standards I mentioned in this world are not all done by the same organization, but they do have to be done. And IEEE is a particularly good place to do that. Now, there's always discussion of when is the right time to standardize. It's too early because the technology hasn't moved forward enough. We should let people struggle with technology and see what happens in the technological space. Let the winners decide, and then we'll standardize those. And then others will say, well, that's probably too late, because once the marketplace has chosen winners, there's really no need for standards that expand the marketplace. There's lots of debate on this subject. There's probably no good answer. But I would point out that there are lots of examples that I'm familiar with, and I've been involved in standards for probably 40 years, where the development of a standard in the same time frame as the existence of commercial competition helped create a massive marketplace that I don't think would have been created otherwise. And one example that came to mind, thinking about this, was, as I say, all of you are probably reading your email and playing online games now, and you're using a Wi-Fi connection to do that. And probably you know, since you're here at an IEEE conference, the history of Wi-Fi. But let me just tell you a bit about how we got from there to here. NCR announced a proprietary WaveLAN product in 1988. It was 1 megabit per second. Well, it wasn't really 1 megabit per second. It was marketed as 1 megabit per second. If you got a quarter of that, it was probably good. Zircom came out with an implementation, another 1 megabit per second product in 1994. I had one of these access points and clients. It was $1,500 for the access point and $600 for the client card, which was PCMCIA. I don't know if any of you remember that, but you had to plug a client card into the access point also. It didn't come with an access client card, so you had to buy a client card for the access point, and then each client was $600. That was a megabit. That was in 1994. These technologies were contributed to IEEE, and the group started up, and in 1997, 802.11 was approved. The first 802.11 standard was a megabit. There was a 2 megabit option, but it was the same speed. And of course, just recently we've had 802.11 AC 2013 approved. That goes up to 7 gigabits per second. Plus, we've created a multi-billion-dollar market. There were plenty of proprietary choices available, but the vendors decided it was better for them to collaborate to create a bigger pond through the auspices of the IEEE, and created a market which has enabled all of us to benefit from wireless connectivity, and that group is continuing. If 7 gigabits a second isn't enough, there'll be more, and the technologies are critical to Internet of Things as well, because some of these things are become connected through Wi-Fi. Now, arguably, you know, since this is what happened, we don't know what would have happened without the standards, but I maintain that IEEE's auspices in generating the focus for these companies to work together created this huge market for Wi-Fi, and not just Wi-Fi. They've enabled all of these laptops. What good would the laptops be if we had hundreds of RJ45 Cat5 cables snaking around on the floor to connect your laptops? They wouldn't really be the same useful devices that they are today. So this is what the IEEE can do to catalyze a marketplace through the development of standards, and I maintain that this is what we have to do to make the intercloud work and the next platform of computing. Now, in the cloud space, one thing we're not short of is organizations working on specifications and standards. Just a little standards geekiness. If it's a formal standards organization, an accredited standards organization, or otherwise recognized, we call them, the documents that they produce, standards. If it's not, we tend to call them specifications. But for civilians, sometimes those two terms are confused. This is a list. I got tired of updating the list. It's really obsolete. There's many more people that could be on the list. The font gets so small that it's not really useful. Why are all these folks working on cloud standards? Well, a few reasons, one of which is they recognize the importance of cloud computing. But if you connect that with what I said at the beginning, the problem is for this next platform of computing, we need to be looking at a higher level than just cloud computing standards. We need to look at a top-down level, and that's the challenge. It's not really being done. The IEEE, as I said, is uniquely positioned to impact this world and develop this next platform of computing. I've listed a number of the initiatives that are going on under IEEE auspices, either the Future Directions Committee or the IEEE New Initiatives Committee. Some of the fonts are a little small, but we have smart cities, cybersecurity, excuse me, rebooting computing, cloud computing, green ICT, Internet of Things, smart grid, life sciences, software-defined networks, and transportation electrification. This is what's been initiated so far. There are opportunities to go forward with new initiatives in the IEEE that are not listed on this. And in addition, there are numerous standards projects related to all of these areas. I listed 3 related to cloud computing. I'm going to talk about those. There are standards in the space of Internet of Things that are really crucial, and many others. The purpose of this slide is to give you the idea that IEEE is ubiquitous in this space and uniquely positioned to create an opportunity for elaborating this new next platform of computing. As participants in this conference, I want to encourage you within the Consumer Electronics Society and other societies to take your ideas forward and help make this platform happen, so you will be the people that are involved in the generation of this next platform of computing, just as people like Vint Cerf and others are seen as luminaries from the age of the internet. I think the changes that we'll be seeing now in this next platform will be of greater impact on humanity than the internet. And if you believe that, you're in a perfect position to make a difference in how that goes forward. Many of your talks and papers at this conference bring out your expertise in parts of this space. So take that interest, expertise, and knowledge and contribute it to the evolution of this platform. Let me talk now about some specific projects that are related. Briefly, IEEE P2301 is a project to make sense out of the multiple cloud computing standards projects that I mentioned earlier. It's something that, to my knowledge, is unique in the IEEE in that we're not going to, in P2301, develop a new standard. Rather, we're going to create a set of profiles for people who are interested in elements of this next platform of computing and point them to existing standards work that's going on anywhere in the world. So, for example, if you're interested in building a public cloud, what standards should you take a look at? And so P2301 is designed to comprehensively look at standards or specifications that are developed anywhere in the world by any organization and point interested parties to those standards so that they can use the standard or participate in the development of the standard. And to my knowledge, this is unique in IEEE standards. So it's an ecumenical project. It's not a standard itself, it's a guide, which means it doesn't say you shall do something. It says take a look if you're interested in building a private cloud, take a look at the following standards or projects. And that group is chaired by John Messina, who is from the group at NIST, the National Institutes of Standard and Technology, that created the NIST Cloud Vocabulary. And any of you who are interested, please go to cloudcomputing.ieee.org/standards and connect with John. He's very interested in your participation. The second project I want to mention is P2302. I talked earlier about the need for standards to make the intercloud federation work. This is the fundamental piece of that project. P2302 is designed to create an infrastructure that multiple clouds can support, allowing you to write applications that run across multiple clouds transparently. Let me suggest that 5 years or 10 years from now, most of the processing that's happening in clouds will not have been initiated by a person, they'll have been initiated by another cloud. There'll be people on the edge somewhere asking for things to happen, but then that will ripple through the intercloud, and clouds will arbitrate based on resources, time of day, temperature, cost, legislative, regulatory issues, and so forth. The jobs will percolate through the cloud of clouds until they're executed in the most effective way possible across multiple clouds. For that to happen, we need P2302 and lots of other stuff. So this project we started a couple of years ago. Deepak Vij is the chair of that working group. It is designed to build a standard. Of course, IEEE standards are all open consensus-based voluntary standards. They're not regulatory standards with some minor exceptions. And so it's up to the user and the vendor to decide what standards they want to have conformant. Now, clearly, if you want to buy a Wi-Fi adapter, it has to comply with, in the US with FCC regulations. So, but I won't get into too much detail on that. But suffice it to say that P2302 is designed to make the intercloud work. And if you're interested in participating in that, Deepak Vij, again, cloudcomputing.ieee.org. The third piece of this is a project that hasn't been approved yet. It's a study group for adaptive management for cloud computing. And as I said earlier, this whole model really only works if we remove the telephone operators. To do that, you need to manage the resources adaptively, autonomously, without human intervention. And Joel Fleck from HP Labs is chairing this study group. He's also very interested in having participation. This really is the key to making this autonomous, independent system, Skynet, basically, that is needed for this effective intercloud vision. And Joel would love to have your participation. The fourth leg of this stool, a key part of our project, was an insight that it really wasn't a good idea to build all of these standards in rooms like this with people around tables and laptops and overhead projectors, but we really needed to involve the real world and try out these ideas dynamically in real time. So we created the Intercloud Testbed. That's chaired by Joe Weinman, and you're also invited to participate. It's an activity of the IEEE Industry Connections Program. These are the founding members of the group. Many of these organizations have invested resources in terms of hardware and software, as well as people to write code in these university programs to test out the algorithms that we've been developing in P2302. The idea here is to build something that would ultimately look like a connectathon, where vendors who wanted to test out their conformance to these standards or potentially suggest new standards would be able to connect their assets to this intercloud and see what worked, see what didn't work, and improve the parameters and performance and so forth. We intend to actually deploy this in the future at IEEE cloud-related conferences as a way for the participants in the conference to get access to the resource, and at the same time provide a way to load the resource and see how it performs. And we've got participation of a number of other companies that aren't listed here that haven't been announced by name, but are very famous. And again, you can access this by looking at cloudcomputing.ieee.org/intercloud. I mentioned the cloud computing program. That's really what happened as the next phase of the IEEE Cloud Computing Initiative that I talked about last year. I started that initiative 3 years ago, and the initiative time frame is 3 years, and we're expected to transition the initiative to sustainability and long-term home inside the IEEE, and we've done that. We've moved all the assets of the Cloud Computing Initiative into a new structure called the IEEE Cloud Computing Program. The Consumer Electronics Society is part of that activity, along with a number of other societies, and we're encouraging participants from the various societies to become members of this. There also is a special community which you can join at no charge as an IEEE member, since many of you will be renewing your membership or have renewed your membership, and if you haven't, please do. But there is a cloud computing community which you can join that'll give you visibility in all of these activities going forward and help key you in on what we're doing. So as you renew, or if you've renewed, go back and take a look, search for cloud computing, it's free. That's the end of my presentation. I tried to allow for 15 minutes of questions, and I think I've done that. And I'd be happy to answer any questions, elaborate on anything, take any criticism, any free goodies that anybody might have. Okay, it's Bob. Of course it's Bob.
Where does OpenStack fit into this?
Pardon me?
OpenStack.
OpenStack. So we've reached out to OpenStack and suggested that we'd like to have them participate in this, and there have been some ongoing discussions, but nothing formal at this point. As you saw from our earlier slide, there are many activities in the cloud space underway. IEEE doesn't have to be the only developer of standards or conferences or publications in this space, although we think that we have a role to play in all of those areas, and as well as the 7 tracks that I mentioned. But we'd love to talk with OpenStack further and intend to keep pursuing that discussion. Yes.
Good morning. Thanks for coming by. My name is Paul Hall from Microsoft, and if you think about some of the particle physicists, they've been doing fun things with the ability to take data at like the Large Hadron Collider and analyze it worldwide. Is that the sort of thing that you think is going to become possible with some of these things? Yeah. There's a lot of those areas too.
So it's interesting in going around the world and talking to people about cloud computing and the SNCS platform. There seems to be some competition in the question of who has the biggest data. Now, if you think about that, it's not surprising, I suppose. And there's some question as to what big data is and what isn't. But those folks have a lot of data. There was a wave of computing, which didn't show in my slide, called grid computing. And a lot of the grid people are now transitioning to cloud computing. In fact, depending on who you talk to, they'll say that they invented cloud computing. And the cloud computing guys just took grid computing and moved forward. We could get into a discussion of whether that's true, because the grid workloads are very, very different from a typical cloud workload. But it is true that those guys have a huge amount of data to process, and as cloud computing offers much more cost-effective, scalable, on-demand processing, they're changing their algorithms to live in this cloud world. The fact that a certain amount of data suddenly becomes practical to process is only going to encourage them to generate more data. That's what's happening in all these spaces. Whoever, thinks that their data is at the peak is just the next step up the mountain. And so we're talking with those folks, and a number of the people involved in our P2302 group, in the 2301 group, and in the test bed are those kind of particle data folks who are helping us to write these standards so it's going to be useful for them. And as various cloud service providers try and grapple with these different kinds of workloads, I think they'll find the longer-term answer is developing an infrastructure that's capable of handling all of these kinds of workloads, because we're going to drive the cost down to the point where it's cost-effective, even if you didn't write the algorithm for that infrastructure.
Yeah.
Another question here.
Kim?
Hi, Richard.
Steve, morning, and thank you very much for all the work you've given and insight you've given into this challenge for the Institute and the industry and society. My question is from the 5 days here at the CES and dialogues we've had with other industry groups in the last year since you spoke here last year. The Internet of Things has blossomed into this incredible marketing term, and 50 billion devices here and $17 trillion here. And while we've been trying to monitor all the groups that are aligning with the Internet of Things, it's nothing without the intercloud direction you seem to have. Do you see any way that we in the IEEE and the ICCE, being part of the new group here, can extend the outreach here? Because not all the members of the Internet of Things are IEEE members. A lot of the engineers, of course, are. But I think we can lend some sanity to what right now seems to be a half dozen competing groups that don't want to be left behind, but don't have the technical interconnection view that you and the members of the group have. So any insights you have there that we can be your ambassadors would be appreciated.
Well, I'm glad you asked that question. In fact, I now realize there was something I wanted to say about that very topic, and I forgot to say that. So thank you for asking the question. I think it's really a fundamental question that we in the Consumer Electronics Society should think about. I remember at the beginning of the Cloud Computing Initiative, when I first started thinking about proposing it to the IEEE, and I was in the Computer Society at that time. I've joined Consumer Electronics Society since then. I realized there were two organizations in IEEE that I had to get involved in this cloud computing space that weren't involved in at that time. So this would have been really more than 4 years ago, 5 years ago. The first one was Consumer Electronics, and the second one was Society for Social Implications of Technology. Many of you have probably not heard of that group. Most IEEE volunteers have not heard of that latter group, but we do have a society that is concerned about social implications of technology. And if there was ever a time to get them involved, this is the time. And so I've been consciously inviting them to the Cloud Computing Initiative meetings 3 times a year and talking with them, and they're involved with our new Cloud Computing Program Steering Committee. But to the Consumer Electronics Society, I think that Internet of Things is consumer electronics. It is about consumer electronics. And while people are talking about the size of the marketplace, and I believe those numbers, nobody has a clue how to get there. There's no standards, there's no vision, there's no high-level architecture. Nobody knows how to do that. If this group can't do that, it's not going to happen. So what I'm saying is, just like it took the IEEE 802 people and their dedication and their vision to make Wi-Fi work, it's going to take the IEEE, because of our IEEE footprint. Just, you're here at an IEEE conference. We're a huge conference provider. But the IEEE is involved in education, both professional education and academic education. We do curricula. We're involved in standards, of course, as I mentioned. We're involved in regional activities. We're involved in publications. You know, we have many, many publications. We started 3 in the cloud computing space. We have to get our collective consumer electronics act together in the IEEE to make this happen. Otherwise, it's going to be a long, drawn-out process with incompatible standards, Betamax, VHS. It doesn't make sense to do it that way. Sensors and actuators today don't all work together. I was on the IoT panel that the Standards Association put on, I'm saying a couple of months ago, in Silicon Valley. And one of the speakers on the panel was, I believe he was from Mass General. And he said that preventable medical error was the #3 cause of death in the US. And to a large extent, the preventable medical error had to do with the fact that these medical electronics devices are incompatible, non-standard, and various pieces don't talk to one another. So the insulin pump and the blood pressure monitor don't talk to one another. The alarms go off, and the doctors and nurses don't have time to check where the alarm is coming from or what to do about it. These are all things, and it's just an example of what's going to be happening in the Internet of Things world. This group, Consumer Electronics Society, is uniquely positioned to make a difference here. More than computer society, more than communication society, this is the place. That's why I'm here. That's why I started talking with Steve Dukes 4 or 5 years ago about this. You're the people who can make a difference and create this future that you want. Thanks for the question.
Shall I speak? Real quick. First of all, sir, I just joined you on the Board of Governors. I missed you the other day. And we're going to have a panel on this subject tomorrow afternoon. So I invite you to come to that conversation. I've been talking to Lee Stogner, and he says, are we either too late or too early or just right for a standard? And there are at least 150 companies or consortia that I know of who think they're going to tell the rest of us how the Internet of Things is going to work. That's too many. But in that chaos, we, the IEEE, may have some value to add because we're trusted and respected. Done.
So,
Thank you.
let me answer that. I think that's an excellent point. I will come to the meeting tomorrow. I think you're right about the IEEE reputation. We don't have an axe to grind. We're not promoting any particular products. We're here, as the tagline says, advancing technology for the benefit of humanity. We can't do that without you, right? The volunteers. You're the ones who make this happen. And if you want to see the world advance in this space and not become Skynet, you need to work with the IEEE to make the standards happen, to make that world happen. I think people are nodding at me and so forth. So thank you very much. I'll be here the rest of the conference. Again, thank you for inviting me. I'm thrilled to be here, and I'll look forward to talking with you at the break. Thank you.
Thank you very much. Excellent speech. Thank you.